Okay, good morning friends. Today we will have a tutorial session. We will be working out a few problems on Bode plot and positive real functions, if possible something on synthesis, two element synthesis of driving point impedance functions. The first problem is given a Bode plot like this. This is 1 by root 3 t. This is 1 by t. Okay. This is 12 dB per octave, and this is minus 6 dB per octave. This value is 3 dB. Estimate these frequencies omega c and omega d, this frequency. Omega c is how much, omega d is how much, and then determine Gs. Okay. So, for this problem, this is the dB gain, this is the 0 dB line. So, could you suggest the function like Gs, what it would be like? Gs will be some constant times, it is a slope going up at this frequency. Okay. So, 1 by root 3 t, let me call it omega 0, okay, omega 0, then it will be 1 plus s by omega 0 whole square. This is 12 dB per octave whole square, all right. Then okay, 1 plus s by, okay, 1 by t will be how much then? Root 3 omega 0. So, if I call this 1 by t is equal to root 3 omega 0. So, s by root 3 omega 0, then any other answer? Squared cubed. So, it was going up by 12 dB and it is falling by 6 dB. So, it will be 3 times 6 dB. So, cubed. Okay, then at what should I write? S by omega d, again it is from 6 dB it is coming to, why should it be squared? Why should it be cubed? Now, it is being raised by only 6 dB per octave. Okay. So, you are beaten. Now, what would be omega d and omega c? What is this gain? This is to be calculated, all right. That is, you call it some p. What is p? So, this is also to be determined. How much is p? Could someone tell me? 12 dB per octave. Now, you are going to a multiple of root 3, is it not? So, root 3, what would be this gain? Yes, what would be this gain? It is at a slope of 12 dB per decade. No, at 3 times omega, say at root 3 times omega naught, that means the frequency is increasing by root 3. So, how much is 20 log of 1 by root 3? Log of root 3, sorry, 20 log of root 3. 12 dB per decade is basically 40 dB, 12 dB per octave means 40 dB per decade, all right. So, 20 log of root 3 into 2, n is equal to 2, is it not? So, how much is it? 40 log of root 3 is 1 by 2, log 3 is 0.477. So, 20 into 0.477, about 9.5 dB. Is that okay? At 2 times this, it would have been 12 dB. It is a little less because root 3 is less than 2, 1.732. So, at that frequency it will be less than 12 dB, it is approximately 9.5 dB. Okay. Now, when does it become 0? How much is this fall? 9.5 dB. So, at 9.5 dB with a rate of fall of 6 dB, how much is this frequency? How much is this frequency? 9.5 dB. Had it fallen at the rate of 12 dB per octave, it would have been that much time, that is root 3 times further, but it is root 3 into root 3, 3 times 1 by t, is it not? If this is rising from root 3 to some height, so 1 by root 3 t to some height with 12 dB per decade per octave slope, with 6 dB, that means with a slower rate, just half the rate of fall, it will be twice that multiple, is it not? So, this is root 3 times. So, it will be root 3 multiplied by root 3, is that all right? So, this will be 3 times omega c is 3 times 1 by t, or 3 times 3 root 3 omega naught. Is that okay? Then you are having a fall of 3 dB with 6 dB, with 6 dB fall, I mean rate of fall of 6 dB, 3 dB is obtained at what value? Omega d is how many times omega c? Had it fallen to 6 dB, then omega d would have been twice omega c. So, at 3 dB it will be root 2. So, omega d is root 2 times omega c, that means 3 root 6 omega naught. Is that all right? So, once you have identified these frequencies, just put the values. Is that okay? How do you determine k? After doing all that, how do you determine k? 20 log k is 20 log of k is 20 log of k. No, at a very small frequency, all these will be knocked off. 20 log of k is 0. So, k is 1, is it not? Is this all right? I may be wrong, correct me if there is any doubt. There is another problem. This is at 10, this is at 40, this is at 100, this is 6 dB minus, this is 0 dB line, and this is minus 12 dB per octave. This is 6 dB per octave, almost a similar problem. This is dB gain. What would be, once again, what would be Gs and this frequency omega c and Gs. So, this is going at a slope of 6 dB per octave. So, what could be the structure? K into S in the numerator, then 1 plus S by 40, okay. Then S by 100 what squared, is it all right? And then this will be 1 plus S by omega c squared, is it okay? From minus 12 dB it becomes 0 dB. Now, what is omega c? From 6 dB per octave, if that is a slope, so from 10 to 40, how much will be this height? 10 to 20, 20 to 40. So, there are 2 octaves. So, it will be 6 plus 6, 12, is it not? 6 dB per octave. If you double it, you get 6 dB increase. So, 10 to 20 it will be 6, 20 to 40 it will be 12, another 6. So, this is 12 dB. Okay. So, from 12 dB per octave, if it is falling, so how much is this? It is falling at the rate of 12 dB per octave and it has fallen by 12 dB. So, how much is this? This frequency 200, 100 to 200, this is the octave, and 200 to omega c it is 6 dB. So, how much is this? Omega c, how much is omega c? 200, instead of going to 400, it is not an arithmetic mean, root 2. Instead of 2, it will be 2 to the power half, it is a power. So, omega c is 200 root 2, all right, 282 approximately, is it all right? So, substitute that omega c, you get the form. What about k? What about k? How much should be k? A 6 dB per octave line, other contributions are not there. At a low frequency, these are all insignificant. What is the contribution of S? Had there been no k, S would have been a line through 1. S is a plot which is passing through omega equal to 1, is it not? Now, instead of passing through omega equal to 1, it is passing through 10, that means this is brought down by how much? It is 1 decade, 1 to 10 is 1 decade, 1 decade corresponds to 6 dB per octave is equivalent to 20 dB per decade. So, in 1 decade it is 20 dB. So, you have given a boost in the negative direction by 20 dB. So, how much is k? How much is k? 20 log of k is minus 20. So, k equal to 1 by 10, log of 1 is log of 10 is 1, So, minus 1 means 1 by 10. So, k is 1 by 10, is that okay? So, this will be the transfer function. Now, another problem on Bode plot. This is 1, this is 5, this is omega c, okay. This is 12 dB per octave, this is 6 dB per octave, and this is 26 dB, this is dB gain, okay. This is 0 dB line. So, what would be GS like? First of all, what would be this height? This is 26, 6 dB per octave. So, from 1 to 5, how much is the fall? From 1 to 5, how much is the fall? 6 dB per decade. So, how much is this fall? How much is this? 6 dB per octave. So, 1 to 2 6 dB, 2 to 4 another 6 dB. So, 12 dB, but then 4 to 5, so you take 20 log of 5, log of 5 is 0.7, 0.7 into 20, it is 5 times this frequency, 14 dB, is that all right? So, I call it P1, this small height. So, P1 is 14 dB. So, how much is this? This is 5. How much is this? 26 minus 14, 12. Is that all right? So, 12 plus 6, this is given as, sorry, this is given as 6 dB. Again, this is also given as 6 dB. So, 12 plus 6, 18 dB fall is taking place. So, how much is this omega c? If it is a multiple of 6, then you take the octave threefold, 5 to 10 one octave, 10 to 20 another octave, 20 to 40 another octave. So, every time per octave you are having an increase of 6 dB, 6 dB, 6 dB like that. So, for an 18 dB there is any multiples of 6, the calculation is very simple, is it not? So, 5, 10, 20, 40, okay. So, omega c is 40. So, once you know this, GS is very simple, k into 1 plus, first one is taking place at 1. So, S by 1 into 1 plus S by 5, is it not? And then in the numerator it will be 1 plus S by 40 whole squared. From 12 dB it is coming to 0 dB. How much is k? When S is very small, 20 log of k is 26. So, log of k is 1.3, 1.3 is 0.3 is corresponding to log 2. So, 20, is it not? So, k equal to 20. So, k is 20 and this is the function. Is that all right? Let us take an interesting problem. There are two black boxes. this is L Henry, R resistance, C farads. The condition is R squared is equal to L by C. ZS, show that ZS in both the cases are same. That means this ZS is having a value R. Given this, prove this. Okay. The second part of the question is, this is given, you have to prove this. This is part 1. Part 2, by any measurement, any external measurement, can you identify this one from this one? Can you identify that this is a pure resistance and this is not? Okay. We will take up, okay, identify by any measurement, that means any external measurement. You carry out any experiment that you want, make any measurement and identify the networks. Okay. So, let us compute the impedance function ZS. Is it all right? Okay, thank you. How much is ZS? It is RC combination R plus 1 by CS in parallel with R plus LS. Okay. So, that gives me R plus 1 by CS into R plus LS divided by R plus 1 by CS plus R plus LS. Okay. How much is this? R squared plus R into LS plus 1 by CS plus L by C. Is that okay? Divided by 2R plus LS plus 1 by CS. Numerator is L by C is R squared. So, R squared plus R squared, that gives me 2 R squared plus R into LS plus 1 by CS divided by 2R plus LS plus 1 by CS. Obviously, R can be taken common. That means, for any frequency I measure the impedance, it is always R. So, how do I distinguish? I have chosen say 1 ohm, 1 farad, 1 ohm, 1 Henry. Then effective value will be always 1 ohm irrespective of the frequency. S can be anything. Okay. So, you have to suggest a method to identify this. Could you suggest anything? Huh? Bode plot will not give you, Bode plot will give you a constant value R. Any plot, see function value GS is R, it is a constant. So, by that you cannot identify, you have to devise an experiment by measuring something, by observing something, you may be able to tell that this is resistive and this is not. Let us have a network like this. This is a black box. Okay. If I have a switch initially kept in position 1, what do I observe in the ammeter? For this circuit, V by R will be the current in the ammeter, is it not? In this circuit, this will get charged up to V volts and there will not be any drop across the inductor because current will be stabilizing, no di by dt. So, the entire current will flow through R, this R, is that all right? So, there will be a current through this, is it not? These are two energy storing devices, all right. Now, if I put this on, suddenly put the switch onto position 2, what will happen to this? There is a voltage V that is appearing across this, there is no current through this and there is a current that is V by R that is flowing through this inductor. Now, because there is a capacitance which is fully charged, all right, this is charged to plus and minus. So, this current, can it flow through this? This current, it will try to maintain the same current. Had there been no connection here, it would like to maintain that current, there can be a current, but then there is a short circuit path, there is some kind of a resistance because this resistance is present, this resistance is present, whereas so far as these two terminals are concerned, there is a short circuited path. So, initially this will try to maintain a current through this, is it not? This V by R will be initially flowing through this, some part will gradually flow through this also because this will try to discharge in this manner. So, both of them will be additive, there will be a current, but this is a shorter path. So, there will be a large current flowing through this ammeter. What about this? If I short it, no current. So long as there is no source, resistance cannot withhold any charge or flux. So, there is no energy storing device. So, this will not show any current, whereas this will show. Is that all right? So, this is a simple experiment. You need an ammeter and a voltage supply, and you can see this will be a good indicator. There is another experiment, an extension of this. We have R and C, R and L. Once again, R squared is equal to L by C. All right. What would be ZS? Prove that ZS is equal to R. So, once again it is RL parallel combination, R parallel SL, series combination with R parallel SC, 1 by SC. So, it is equal to, this is ZS, equal to R into SL by R plus SL plus R into 1 by SC by R plus 1 by SC. Okay. Once again, if I multiply R plus 1 by SC plus R into 1 by SC into R plus SL divided by R plus SL. So, R squared plus R into SL plus 1 by SC plus L by C. Okay. So, L is equal to, I will put C r square, wherever there is L I will put C r square. So, I get R into R squared into L is C r square, R square S L into S plus R into L by C, which is R squared. So, total R cubed plus R square by S C plus R into L by C, that is R cubed. Correct me if I am wrong. Is that all right? Again R squared plus R S into L is C r square plus R by S C plus R squared. Okay. So, that gives me 2 R cubed plus R cubed, 2 R cubed plus R squared by S C plus C R 4 S divided by R squared 2 R squared, all right, plus R by S C plus R cubed C S. So, you can see the ratio, if I take R common from the numerator and denominator will get cancelled. So, that is equal to R. Is it all right? Now, the second part I leave it to you as an exercise. How do you find out this network? Then another problem, we have a network which is to be identified. If you apply a unit step of voltage, then the current is A1 e to the power minus t plus A2 e to the power minus 2t plus A3. If you apply a unit step of current, this is case 1. If unit step of current is applied, I will call it V1, I1, similarly I2, then I get a voltage across the terminals as B1 e to the power minus 4t plus B2 e to the power minus 5t plus B3. All these are constants, but not known. Okay. A's and B's are constant coefficients, but unknown. If I apply a steady DC for a steady DC steady current of 1 ampere, we get for a DC voltage of 50 volts. What will be ZS? Question 1, what will be ZS? And next question is it a PRF? Is it positive real? you have to give reasons. So, let us see the first condition. I1t is this. So, how much will be I1s? I1s is A1 by S plus 1 plus A2 by plus A3 by S. So, that will be sum PS by S into S plus 1 into S plus 2. Okay. What is the corresponding V1S? Input is unit step, is it not? So, 1 by S. So, what could be ZS like? V1S by I1S. Okay. So, this divided by this, how much is it? S plus 1 into S plus 2 divided by some PS, not known as yet, but the numerator factors will be S plus 1 and S plus 2. Okay. Next you apply V2S is how much? You apply I2S as 1 by S, is it not? Second time you are applying a unit step of current. So, I2S is 1 by S. What is the corresponding V2S? B1 by S plus 4 plus B2 by S plus 5 plus B3 by S. So, it will be sum QS by S into S plus 4 into S plus 5. Okay. So, how much is ZS? V2S by I2S, and that will give me sum QS by S plus 4 into S plus 5. Okay. So, ZS from these two, you can see in one case I am getting the zeros, in the other case I am getting the poles. So, I can write this as sum k times S plus 1 into S plus 2 by S plus 4 into S plus 5. Is that okay? Okay. You are given a network function, network to be identified. You are applying an input voltage of step function ut. Input is step, unit step. So, how much is its Laplace transform? 1 by S, agreed? Current is in this form, these A1, A2, A3s are not known. So, what could be the current transform? I1S, A1 by S plus 1, A2 by S plus 2 plus A3 by S. So, that will be a common denominator, S into S plus 1, S plus 2. Numerator after all these additions, let it be PS. So, I have identified this. So, V by I, V1S by I1S, that will give me ZS. So, that will give me S plus 1 into S plus 2 in the numerator. So, ZS has a numerator which is this, that means that these are the zeros. Denominator I do not know. From the second case, I am getting similarly the denominator ZS equal to V2S by I2S, that is S plus 4 into S plus 5. So, by the two experiments, I am able to identify the poles and zeros. So, what could be ZS? It will be sum k times S plus 1 S plus 2 divided by S plus 4 S plus 5. Okay. And then for a DC voltage of 50 volts, the steady current is 1 ampere. So, what is the voltage by current ratio? 50 by 1, 50 ohms. And how much is that? In this, what do I put for a DC? What is the DC impedance of this? Put S equal to 0. So, that is 1 into 2 by 4 into 5, 1 by 10. So, K by 10 is equal to 50 ohms, is it not? 50 volts, 1 ampere. So, k equal to 500. Is that okay? Okay. So, 500 into s plus 1 by s plus 2 by s plus 4 into s plus 5. Is that okay? Is it a positive real function? Second part is it a positive real function? Roots are in the left half side, left half plane, then the degree difference is restricted to 1, all those conditions are satisfied. So, but no, that is only for RL or RC, it can be an RLC synthesis, that is possible. So, we are not concerned about that. The test that you have to make is even ZS, if I put S equal to j omega, should be greater than equal to 0 for all omegas, is it not? So, let us find out the even ZS. This is S squared, I can write this as 500 into S squared plus 3S plus 2 divided by S squared plus 9S plus 20, is it not? So, even part is S squared plus 2 into the even part of the denominator is S squared plus 20 minus 3 into 9 S squared to be evaluated at S equal to j omega. How much is this? S 4, there is omega 4 plus 20 S squared plus 2 S squared, 22 S squared minus 27. So, minus 5 S squared. So, that will become plus 5 omega squared. If I put S equal to j omega plus 40, this is always positive. So, it is a positive real function. Can you realize it by RL or RC? No, because the poles and zeros are not interlacing, 0 0 pole pole, they are coming in this order. So, it will not be possible to realize this by RL or RC. We will see later on how this can be realized by RLC, that will be taken up later, but we know it can be realized because this is always positive. Is that okay? There is another problem. Consider the admittance function Ys S squared plus half S plus 1 divided by S plus half into S plus A1, where A1 is real and positive. Question is determine one value of A1, determine one value of A1 such that Ys is not positive real. Is not positive real. Second condition is determine A1 and also the frequency omega 1 such that at that frequency y j omega 1, the real part of this is equal to 0. Okay. So, let us once again find out the condition for positive realness. Ys, if I break it up, it will be S squared plus S by 2 plus 1 divided by S squared plus A1 plus half S plus A1 by 2. Okay. So, even Zs or even Ys, what is the even part? a square plus 1, mind you earlier also when we are considering even part, this m1 m2 minus n1 n2 that we derived divided by m2 squared minus n2 squared, the denominator was always positive. So, we are not considering the denominator, this is to be divided by a squared plus 20 whole square minus 81 a squared, but that is always positive, is it not? So, here also we will consider only the numerator of that even ZS. So, a squared plus 1 into a squared plus a1 by 2 minus this into this half a1 plus half a squared. This is to be evaluated at s equal to j omega. Though I am writing even ys, but I am not writing the denominator, which is a positive quantity. I should better put arrow. Now, how much is this? If I put s equal to j omega, omega to the power 4, okay, plus if I put s equal to j omega, this minus sign will become plus half of a1 plus half minus a1 by 2 into a squared and 1 into a square plus 1 this whole thing into omega square. Correct me if I am wrong. Half into a1 plus half, this is a square, this is containing a square terms. A square terms will be always generating a minus omega square. So, I have taken the minus 1 as positive and this one as negative. The coefficients coming out from here is a1 by 2 and 1, okay, plus a1 by 2. Okay. So, this is omega to the power 4 plus, if I simplify this, a1 by 2 will get cancelled and 1/4 and minus 1. So, minus 3 by 4. So, omega 4 minus 3 by 4 omega squared plus a1 by 2. Okay. So, omega 4 minus 3 by 4 omega squared plus a1 by 2. Is it negative for any value of a1? Any value of a1, is it negative sometimes? When is it negative? Suggest any value of a1 so that it is negative sometimes. Would you like to put some values, keep on trying it? Yes. Now how much is it? For what value of a1 will this be less than 0 at least for some omega? No, a1 is positive. A1 is positive. You suggest 1. If I put 1, then this is basically omega squared plus a1 by 2 whole squared plus 2 into root over of a1 by 2 into omega squared. If I add this and subtract it, okay, so that I can choose, what should I choose? This plus this plus this or minus this, either way. Okay, let us see. It is better to see it how it works. Suppose we put minus, this one we choose to include in this, then it will be root 2 a1 root 2 and 2, that gives me this omega square minus 3 by 4 omega square. Okay. This is always positive. Okay. Whatever be the value of omega a1, this is always positive. This can see root 2 a1 minus 3 by 4 into omega squared. This can become negative if 3 by 4 is greater than this term. That is, if root 2 a1 is less than 3 by 4, this may be negative, is it not? So, it may become negative sometimes if this is a condition. So, a1 is less than 3 by 4 root 2. If we take the positive term, on the other hand, it will be omega squared plus root a1 by 2 whole squared minus 3 by 4 omega squared minus root 2 a1 omega squared. Okay. One may write this squared term minus omega square into 3 by 4 plus root 2 a1. Huh? Root a1, sorry. So, a1 will be square. Okay. Thank you very much. So, here is one condition. Does it mean for any value of a1 it will be negative? Though there is a negative term, but this value is generating more values. I mean, this whole thing is giving me sufficient margin maybe. So, for any value of a1 this cannot be tested. So, I should always put the minus sign here and then plus something and then try to see if in that plus term there is any possibility of getting a negative value, alright. Otherwise, this will not be able to identify the actual range of a1, you may be misled. Then the second part is, I think the time is over, I will continue with this in the next class. Okay. Good afternoon friends, we will continue with a few more tutorial problems. Okay. We will take up an example on pole 0 distribution and computation of network values from the pole 0 distribution, network parameter values. First question is, you are given a circuit like this, show that this impedance function ZS has a distribution of poles and zeros in this form. This function has the form like this. So, what would be ZS from here? R plus SL in parallel with 1 by CS. Okay. So, that gives me R plus SL into 1 by Cs by R plus SL plus 1 by Cs. If I multiply throughout by Cs, that gives me R plus SL by S square LC plus RCS plus 1. So, this can be taken as S plus R by L into L divided by LC into S squared plus R by L S plus 1 by LC. Okay. That will always come out to be positive at any point. You can take the derivative and you can show this. This evaluated at j omega. So, if I put S equal to j omega, so how much is jx? This side is jx. So, how much is jx? Is k1 j omega plus j times k2 omega by omega 1 squared minus omega square, because S squared is minus omega square, and similar terms plus k infinity by j omega. So, it will become minus k infinity by omega into j. Now, j will be cancelling with this. So, x is given by k1 omega minus k2 omega by omega 1 squared minus omega square plus similar terms k2, k3 etc., and minus k infinity by omega. If I take the derivative with respect to omega, dx by d omega, this one will be k1. If you take the derivative of these terms, it will be all positive, you can see for yourself, and minus k infinity by omega, this will also be positive, plus k infinity by omega squared. So, all of them will give you positive terms, and hence the slope is always positive with respect to omega. Okay. So, we will stop here for today. We will take up a new topic in the next class. Thank you very much.